Well, hello friends. Today we are going to implement the second part of the pledge puzzle, and it's the another syscall called unveil, which comes from OpenBSD again, and it's sort of a complement to pledge, but unveil, unlike pledge, which is for process capabilities, unveil is for file system capabilities. So the way it works is that you call unveil and you tell the kernel which files and directories that you want to access in your program. And then after you finish telling it which files you're going to be accessing, you make a special call where you don't pass any path, and that seals the list of unveiled paths. And from that point on, you can't access any other paths than the ones you already said you were going to access. And if you do that, then your process will be terminated. So very much like pledge, except for file paths. So this is the API. We just have to pass in a path and what kind of permissions we want to apply to that path. And then from then on, this will be enforced by the kernel, and we can't access those paths. And then here we have so the first argument is path, and the second argument is permissions. So the permissions argument is R for read, W for write, X for execute, and then C is that you would allow the path to be created and removed. So I haven't looked at how it's actually implemented. So I mean, in OpenBSD, and I don't want to know yet. I'm just going to make a, we're just going to figure this out as we go. So we'll implement it based on my understanding of it, and then maybe we'll have to tweak it down the line. But basically, I guess we can sketch out some calls to unveil somewhere that we would use these. So we can put them in the ID program, for example, because we know that ID will need etc password and etc group, right? So we can do something here like unveil. We want to be able to read this file, and if that fails, then we will error unveil, right? And we'll also do group. And we should only be allowed to read. And then finally, we will call unveil with null, and that should signal to the kernel that we will not be able to unveil anymore at this point. So of course, the point of this is that if somebody were to take control of this program maliciously, then because we've called unveil with null, that means that they cannot add any more paths and make them available to the process. So this process, if you manage to take control of ID, then you will only be able to open these two files for reading only. So I think this is a really, really cool mechanism, and let's implement it. So I guess we'll add the syscall wrapper first. We'll just put him next to pledge. Wait, what's that? Oh. I still find myself confused by these copyright headers that I added to the system, but it was time for some big boy copyright headers, you know. So unveil path and permissions. Okay, that's pretty good. And then we'll do much like pledge. We'll just the editor is in kernel mode, so let me just change that. Okay, unveil permissions. All right, and then we'll just set up some parameters here. So unveil params path. And if there's a path, then the string length of path, otherwise 0, and same with permissions, I guess. It's a little bit strange the way that we make syscalls, but the reason that we do it this way, we put everything into a struct and then measure the strings, is just so that we don't have to measure the strings in kernel space. So it's just taking that responsibility away from kernel space. I like to try to do things in user space when they're possible. It feels better somehow. My phone keeps lighting up. I'm just gonna turn it over. I don't know what I did to make it light up so much, but I'm not gonna find out right now. So we will just make this syscall argument struct unveil params, path and permissions, and we will add it here to the list of syscalls. Okay, so then we go to the process class. Next, we'll put it next to pledge, just because it's his little brother. They can be together. And here, let's just start implementing this guy. So, user space parameters. I'm just gonna make a copy of these. There's a little bit of boilerplate that goes on here. So I'll just copy this stuff from up here. There we go. Basically, we're just going to make a copy of the parameters, because when we arrive here in this syscall, then these parameters are on the user space stack. Or they're somewhere in user space memory, basically, and we want to just move the parameters into kernel space so that we don't have to worry about anyone screwing with the memory. Just as a safety precaution. So we will reject overly long paths, I guess. So we say if permissions length is longer than 4 characters, then you're up to no good. And if the path length, we'll validate that in a moment, actually. So path, we actually have a helper for this. So get syscall path argument, params path, params, or maybe we can just do that even. Yes. If path is error, then return path error. Okay, and then we just need the oh, wait, hold on. It's okay for it to be null, now that I think about it, so we gotta handle that. So we'll do it this way. So if params path, if it's not null, then we will try to load it. Path value is error, then return the error, otherwise the path is the path value dot value. All right. And then let's also get the permissions. If there are no permissions, actually, so if params permissions, oh no, hold on. I'm underthinking this. Permissions. I guess we can actually do this in a different way. We can just check up front if params path characters is null and params permissions characters is null. That means that this is the call that disables unveil. So in IDCPP, it's this call right here. So we've set up the unveiled paths, and then from that point, you can't unveil again. And of course, I should mention that if you never call unveil, then the whole file system is available to you. So this is an opt-in mechanism that allows the process to declare what it's going to be accessing. So let's handle the null situation up front, because that simplifies everything else. So here we'll just say m unveil state is locked, something like that. And I guess it's always okay to do this. Okay, and then if m unveil state is eperm, we don't let you unveil after you've locked it. And I guess we should have something here like locked. So we can be in no state. And the veil has dropped, or the veil has been locked. Something like that. Because of course the idea is that you're like dropping a veil over the process. It's the metaphor. And then you're locking the veil. So let's call them those things. That's pretty nice. And we'll just put these up here next to the pledge enums. M promises, where are you? Promises. Unveil state. Start out with no state. So you haven't opted into unveil at this point. And let's let you query that. So unveil state. Okay. And this will be veil locked. Okay. So if you try to change them after you've locked it, we'll give you eperm. I think that's what they do here probably. Eperm, an attempt to increase permissions was made. Or unveil was called after locking, right? So that's fine. And then an invalid value of permissions was used. I guess we can do that here. So at this point, neither should be null. So if anyone is null, but not both are null, then that's invalid input, I think. So we'll just say if params path characters is null, or params permissions characters is null. Inval. All right. And then we know that neither is going to be null, so we don't have to do this part. We can just go straight to the getting the path. Okay. Params. Oh, such boilerplate going on. This thing will validate the string, and if it doesn't work out, then we default. In case it's not in readable memory. Okay, then next step is to parse the permissions, I guess. So let's just say we'll have a bit mask for this. So we'll make some enum like unveil permission, unveiled permission, or we should store this thing somehow. So we'll call it like an unveiled path. It will be a struct, and it will have a we're not going to store it as a string, but we'll store it as a custody. So ref footer to custody. Custody is a parent-child relationship in the file system. So it's like a directory entry, sort of. That's what we're going to cache. And we'll cache the permissions for it. So permissions, I guess. And we'll just do something here like permission read, write, execute, create. What was that last one? It was create, right? Create and remove, something like that. Okay, well, I might not implement this one today, but we can create or remove. We can at least add it to the enum. Okay, and we should make these a bit mask. So like that. Access. So let's walk the string that we got here. So I guess it's length for string, not size. So switch permissions I access. We set the unveil, the path, access, read. And then we just do this very interesting parse. Execute, create, or remove. And if we encounter any other character, then screw you, user. That was not a valid permission. Okay. And finally, I guess at this point, we should add this to our list of unveiled paths. So I guess it should be, what should be the key? I guess the custody is the key, really. So we should look it up. Let's put this in the header so that we can use it. And promises. Here, let's see, a hash map of custody to onPutter of unveiled path. Something like that. And this being a raw pointer is okay because the pointer is owned by the unveiled path object. Maybe they don't need to be hash maps, actually. Maybe we can just put them in a list on a vector or something. Yeah, hash map is pretty easy. We can use that now, and then we'll see if we need to change that up later. So let's see if we can find it. Find. Oh shit, wait, we don't know yet. We have to resolve the path. So VFS resolve path. Okay, we'll get to the object. So okay, now we gotta try to resolve it. So we'll pass in the path and the, I guess unveil has to be called with absolute paths, right? You can't call it with a relative. I'm just going to assume that it doesn't make sense you would pass in a relative path like /foo. That would be really, really bizarre if you could. So let's not allow that, or let's not care. So we'll say that paths are, we'll say that the path has to start with a slash, actually. If path is empty, or no, path value is empty, or path value what is this? Characters 0 is not slash. Okay. No empty paths and no relative paths. All right, and then try to resolve it, and then we can resolve. It doesn't matter what the base is, so we can give the current directory. And I guess that's that. So if the result is an error, then we return the error. But if it worked, then now we have a custody. So we can look it up. Oh, but this is a bit tricky. Because the custody is not unique. You can have multiple custody objects that represent the same parent-child relationship. It's just a description of the relationship. So custody is a parent, and then the name in that parent, and then the inode. The child inode. So what do we store for this? Actually, I guess we can just store the path, now that I think about it. Yeah, we don't have to resolve it here. Maybe we should, but I feel like maybe it's okay if we don't. We'll figure it out as we go. So we'll store the name for now. So process.h unveil path can instead be a string path. Okay, we'll do it that way. We'll see how it turns out. So we'll do unveil paths get, because now actually we can have it indexed by the path like that. Okay. That is a little confusing because I'm not quite sure how this should work, but we'll figure it out. So path, if it's not the end, then if it value let's see, can you increase the permissions? I feel like you shouldn't be able to increase the permissions, right? So if value permissions and the negative of or if the new permissions, or if the new access, sorry, and the negative of the existing access, Access is such a weird name for it, but okay. So we can call these new permissions. So if the new permissions has any bits set that are not set in the existing entry for this, we will eperm. Right. Otherwise, that's good. But if this is a new entry, then unveil paths set path value and a new object. Path value and unveiled path. New permissions. Okay. I think that's a start. All right. And then maybe we should resolve it so that we know what it resolved to at the time when we inserted it. So I think maybe keeping that custody is not such a bad idea, because I would also keep it around, although I'm not sure if that's a good idea, but we'll do it that way anyway. Is that a good idea that it forces the thing to stick around? Okay, let's just implement some access control now. So we'll go into path resolution, because this whole thing should happen in path resolution. So this is the virtual file system's resolve path function. And I think the first thing we'll do here is if current process unveil state is not unveil state none, and then so I think we are supposed to, what are the errors? So attempts to access paths not allowed by unveil will result in an error for eaccess when the permissions argument does not match the attempted operation, or enoent is returned for paths which no unveil permissions qualify. Right. So eaccess for permission failure and enoent if it's not in the list. So I think the easiest way to do this lookup here, let's see, maybe we'll do something like audit unveil. Path and, or wait, we can just write it out here maybe. So we need to be able to look up a path. Unveiled path, look up unveiled path. Unveil paths, get cath value or null footer. So current process lookup unveil path, and we just pass in the path that we're working with. And if there is no unveiled path, we will say enoent. And then if there is one, then we got to look at the access attempt, which we have here in the options. So if options and read write, oops, oopsie doopsie, or options and write only. So if it's a read, or if it's a write access, and unveil path permissions and write. Let's see. So if we don't have write access and we want to write, then e-access. Okay, and then we will check read access. I guess that's, wait. If we're not trying to write, then we are trying to read. Although there's also executes, maybe we should check that first. Or, well, does it really matter which order we check these? Because they're all just fails anyway. Let's just write it out. So if either read write or read only. Read only is such a weird one because it's 0. What am I even saying here? Options and read only. That's strange. So I guess we can do something like this. If the write, why is this so hard to organize? Okay, we'll look at the options. So if it's read write, then we need to look at these permissions. Okay. Else, if options exec, then we need to look at the exec permission. And if it's any other thing, then it's a read access. Then we need a read access. Oof, okay. And then I guess we also had the create, which I suppose we could include here. So if there is a create involved, can even do that one separately. So if create is in the business, okay. So will this work? I have no idea. I feel like maybe it might. Well, isn't this really not fast? Oh, geez, what did I do? I feel like the build is getting slower every day. So what are we doing now? So when we try to resolve a path, we will look if we are in unveil state none. So either we are in veil dropped, in which it's still okay to add more unveil paths, or we're in veil locked, which means that we have like we've locked the set of unveiled paths and you can't add any more. But any state other than none, we care about this. So we're going to audit the accesses or the resolution attempts. This does seem pretty reasonable. So I wonder what would be something else that we could do this on. Look at something like ping. Now, ping is not going to open any files, but he doesn't have rpath, wpath, or cpath, bpath, or anything. So it's already limited, like you can't do any file system stuff. So it's not so useful to put unveil here, but let's go look at somebody who has pledged rpath. What's some interesting utility for that? It's kind of tricky. So, oh, that's really neat. That, like in the Markdown utility, then we pledge rpath, and then after we've opened the file that we want to load, then we drop the rpath pledge so that we're stuck with only standard I/O. This stuff is very neat. Something like ls. I guess we could try to add it here. So with ls though, like you don't want to unveil a specific file, but rather a whole directory. So how would that work? A path that is a directory will enable all file system underneath path using permissions, if and only if no more specific matching unveil exists at a lower level. Non-directory paths are remembered by name within their containing directory. So there are a lot of peculiarities here that I'm not going to implement right now. We're just gonna get the basic mechanism down so that we can start to apply it, and then we can improve on the mechanism as we go. So ID. Right, so I already unveiled all the right things, but what if we didn't unveil the password file, for example? I guess I should have set it up that way so that we could test it. Aha! So now it tries to open the password file and says no such file or directory. And then things fall apart because it expects to be able to open that file. Makes sense. And we should put some logging about this. So we can put some debug logging. Debug current. Rejecting path since it hasn't been unveiled. Okay, and then we can log for all of these. Hasn't been unveiled with C permission. X, and finally the read. Okay, it's a bit cooler. Let's see what it says. So, rejecting path at C pass WD since it hasn't been unveiled. Very nice. So, where can we apply this? Lookup server, maybe? It's already pledging RPath originally, but then it drops that pledge, so he can't read files anyway. We need something that wants to be able to read files. Go look in bin, see what kind of programs we have. Or even better, like who's running? And who has RPath? RPath means that it's allowed to read a file. So RPath, WPath, we both have both of those in audio server, terminal, shell. Why does audio server have RPath? Why do these things have RPath? And I mean, why do they have these things? I don't know. I guess RPath here is for, oh, it's for the, if the themes change. Right, and fonts and stuff. So in Windows Server, we, the system themes and stuff, they are in the /res/themes. And then there's also various other things like the menu up here is populated by stuff in res apps. And there's a lot of stuff in /res. That's like where we keep the resources. So we could actually we should be able to unveil the res directory. That's also where fonts are. But like once Windows Server has started up, it shouldn't need to look anywhere other than in res, I think. Or I guess also at your we will look for something that looks like a path. And we'll see what we can discover. I feel like it has your Windows Server config files in your home directory. So let's see, what do we have? Res themes, res apps, res themes, blah 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 blah. And then it tries to run some programs, of course. So maybe bin needs to be allowed. But let's try to unveil Windows Server stuff. So how would we do this? If unveil res, and we'll say that you can read anything you want in res. If that fails, we will pair and let's also unveil. Well, let's just only try that and see what happens. I feel like this is it's going to fall apart quite quickly, but we'll see. It will be interesting. I would love to be able to run the system with not just very limited access to syscalls, but also very limited access to the file system. So it feels like a really neat thing if you can lock things out like that. So Windows Server now only has access to res. I feel like something here didn't work. Did I do this right? Because it should fail to open other stuff then. Why doesn't it fail? Failed, or actually, hold on. I know why. Because we never changed the state to veil dropped, which we should the first time that you add anything here. So unveil state is veil dropped. And the first time we are here, it should not be fail locked. That will be a grave error. So we'll assert that it's not locked, and then we'll drop it. All right, I got a little trigger happy there. So this should now fail a whole bunch. Yeah, there we go. So Windows Server is trying to open etc passwd since it hasn't been unveiled. Cool. All right, so now we're just gonna add things here, I guess. etc passwd. We'll add them and see what else is needed. Figure out the minimum set of required paths. Okay, now we're in a crash loop. So now we can see here what's being rejected. So home and on opens the config file in my home directory, and then some res stuff. Of course, this should actually allow res, but we didn't do anything directory based yet. And then temp rpc ... something something. So I think one thing we can do, so this is the setup of the RPC socket that every event loop sets up. I think we can actually do the unveil after we've set up the event loop. That's probably okay. We'll just do it a little bit later on. Although the config file, that's what's going to look for my name, so he already needs the frickin' passwd. All right. So maybe we can set it up this way. We'll do it early then, geez. Then let's do it extremely early. So we'll need temp access, because I guess we can remove this afterwards. So we'll allow you to create files in temp. And we also needed my home directory. I'll just take this path verbatim right now. Like that for reading and writing. And you can create it too if you want. Okay, so now we are rejecting temp. And these are both directories, right? So, how are we going to fix this? So we need to allow these when we resolve path. So what's the easiest, most straightforward way to do this? Like, the thing that annoys me now is like ... If there's ... in the path, then it's very irritating, because then you could, like, if temp is unveiled, then you could try to open temp / ... but obviously that shouldn't be allowed. So let's see what we can store for these things. Maybe we should store that it's a directory or not. False. Or should we store a custody? Maybe for directories we should store a custody. That's so weird though. What if it gets deleted? We don't want an unveil to keep something pinned in the file system, right? That would be very strange, because then you could create a user process and then unveil everything and then pin the whole file system down, make it impossible to delete for the super user, and that would be very stupid. So we don't want that. I guess maybe we would want some kind of a weak pointers, but we don't really have a weak pointer to inode or weak pointer to custody mechanism at the moment. So let's do the simplest approach, and then we can improve upon it later. So the simplest approach is to reject paths with ... in them, and to instead just check if they start with the same thing. Yeah, I think that would be the most easiest first draft or first implementation to do here. So if there is one, if there is no unveil path, that means that we can't look it up only this way. We have to actually, what do we do? We can't look it up by whole name. We have to, frick. Okay, I'm just gonna do this the not super efficient way, and then we'll come up with some improvement for this at some point. Unveiled paths. This should really be in its own function. Audit, unveil, validate result path, process unveil, path and options. If result is error, return result. Error. Then we can move all of this gunk up to a new function called kResult, or just kResult actually. BFS. Validate result path. Validate path against process veil. String view path and options. All right. Just a little compartmentalization here. And this will be internal to VFS. So now we can't look them up by string anyway. So maybe we should just keep these in a vector. And we don't need to put them in an own footer, by the way. They can just be like this. Unveil path, string and permissions. Okay, that's pretty good. Is directory. Okay, so no, let's not save that. Ugh. I just feel like I'm just going back and forth here, but so let's forget about the lookup and instead expose the vector directly. So unveil path. unveil paths. There we go. Now we can iterate these guys. Current process unveil paths. Phew. If unveil path dot path starts with if path is equal to unveil path, let's see, and then this will be a separate function actually, so find matching unveiled path. Because we need to forward declare unveiled path. Alright, so we're going to look for it. That's what we'll do with this code. So auto unveiled path is find matching unveiled path for path. Okay, so if they're equal, then it's definitely this one. And if path starts with the same as unveiled path, then it's also okay. But we gotta make sure this starts with, and it also has a slash right after. Path starts with unveiled path path, and unveiled path, or and path length is greater than, or unveiled path length, and path characters without null termination. No, that's so long. And unveiled path length equals. So the next thing in the incoming path has to be a slash. Then this will be something inside the other one. And then of course we should reject anything that has ... anywhere in it. So the easiest way to do that is do we have any stir mem no, we don't have any APIs for looking if something contains something else. String contains, okay, that's good enough for me. So if string path contains slash ... then screw you, I am going home. This is very, very ugly, but fix me. Figure out a nicer way to do this. Okay. So we'll just reject them. So how will this fare? We need to fix the syscall because it's not a map anymore. If or for auto equal to path value. Okay, that's good. And then otherwise, we just append a new object with path value and new permissions. So that's actually slightly nicer. Oh, we have some errors here. On line 764. Validate, that's a success. I guess we can move this check into this guy as well. So if unveil state is none, we'll just return case success. And then we can do that. Then resolve path doesn't have this big, huge blob, but we instead just have a single little thing where we validate against the process veil that takes care of everything. Okay, so why are we def looping now? Rejecting path temp RPC. Okay, are we trying to read from it? I'm a little bit surprised by that, because I think we're only trying to open a socket. See event loop. So, oh, we try to unlink it first. Oh shit, right. So we need to allow all kinds of things. What is unlink? How does unlink open files anyway? Unlink will do path resolution, but it doesn't pass a read. Oh, that's kind of special. I guess we should have some kind of a secret thing that we pass in here. Should pass in a secret. Think internal. Oh, unlink internal. And then in resolve path, we will know that this is an unlink lookup. So we'll go here, if options creat, if options and unlink internal. For unlink. Otherwise we'll allow it. Should make sure that we don't let anyone open things with this. Just making sure that the open syscall envals if you pass this internal stuff. It's a little bit weird to use open flags for this. We could probably come up with some kind of a side value, but maybe this is okay right now. Oh, I should just keep this open. Okay. All right, so why are we still failing? Now it wants to write to it as well. Listen. C local server, listen. What does that do? Call socket and then bind. So I guess in the bind syscall, maybe we try to open for writing. For a local socket, when we open the file, then we open it with, oh, read write, look at that. And create as well. So that's pretty goofy. I think we will let's just unveil it with write access. I think that's fine. I'm not exactly sure how we should deal with socket permission specifically. Okay, and now it's trying to open dev keyboard and dev ps aux. That's interesting. So that's the human input devices. So let's unveil those. Dev keyboard for reading and dev ps aux, which we should maybe rename to mouse. I don't know. ps aux is like this Linuxy name for it. FB0 for the frame buffer. We need that as well. Of course, we could have just opened /dev and allow everything, but it's kind of cool that we don't. Oh, now what? FB0. Oh, shit, we need write permission for it as well. This is interesting. It's interesting to discover what your program needs, right? Oh, shit, we are up and running. Wonder if we can start a program. Yes, we can. Because we can fork, and then the fork child can exec, and that's fine. It's really nifty. And can we change the theme? Yes, we can. Can we reload the config file? Yes, we can. Oops. And it's actually saving the resolution to the config file as well. That's fine. That's really quite interesting. So Windows Server main. Then after this point, we should be able to lock things down. But it would also be cool if you could, like once you've opened these, like dev keyboard and ps aux and so on, we could actually drop all of them. So what if we opened dev for reading, and then after we've set everything up, like before we enter the main loop basically, we just drop that. So say loop. Should make sure that this removes it entirely from the list. Or is that the API that they have in NullPutter? Zero or more of the following characters, right? So blah, blah, blah. Okay, so we'll get rid of dev, and we can get rid of, we should be able to get rid of temp as well, because the socket is open. No need to keep that permission anymore. And etc past WD, I think we can keep that one. Maybe that's okay. This one is really ugly. I don't like that one. I I feel like maybe that we should make like a daemon or something, or config server that processes can talk to if they want to read users' config files instead of every program being able to open them. It would be nice to broker that somehow over IPC instead. But right now we're not going to do that, but I think I'm going to put a big fat fix me here. This should obviously, Windows server should obviously not hardcode this. Instead, we should have a config server or similar that programs to get set user settings over IPC without giving them access to any files. I feel like that would be a pretty good good thing to do, because I like the idea that Windows Server can't get to any of my stuff, but right now we'll let him get to that, but nothing else. Okay, so to make this maximally interesting, of course, wait, hold on, let's add it to the proc file system first of all, so we can see what's going on in here. So we'll add a file, proc pid unveil, maybe. Unveil. And we'll have to add it up here as well. The proc file system is not a beautiful design at all, but it works right now, so we tolerate it. Let's see. I guess we're just going to make a JSON array. Give me a JSON array. This is good. And we'll get one of those. So proc pid, and what did I want to call it? Unveil. Okay, and then for auto unveiled path in process unveiled paths. Just make an array, and the arrays are going to be objects with the path, unveil path dot path, and the permissions. Okay, that's pretty good. And then Windows Server main. Did I null out the unveil thing? No, we forgot to do that. So the last thing we'll do is we'll call unveil with null and null. That makes it impossible to unveil any further. Okay. And we can go and look in proc whatever. Okay, wait, hold on. Trying to open the frame buffer, but it's so maybe it's opening later than I thought. Or no? Wait, it's failing in WS screen. Oh, but I messed that up somehow. Dev should be read write. Oh, fail, fail, fail. Unveil. calling unveil with null goes wrong. Bad address. Wait, why would that fail? Unveil, bad address. I don't understand. Okay, how am I messing this up now? I'm definitely not supposed to be... What am I doing wrong? Does it work without this? Because if so, then something is wrong in the syscall, and we'll have to look at it. Okay, that also fails. Is it this one, maybe? Do these fail? Yes, okay, so they fail. The empty strings, not allowed. Why is that? So, permissions, validate and copy string from user. If that gives us null, but the empty string, maybe the empty string should be okay here. So we'll say that if user characters, if it's null, then we will return null. If user length is null, or 0, then we will return the empty string. I feel like that's the right behavior, because if you're passing in a pointer, but the length is 0, then we'll consider that an empty string. I think that's fair. And then all of this stuff should work if we let it run. All right. So PS Windows Server is PID12. So we go to proc12. Now we have unveil here, and we'll look inside it. And of course it's JSON, so we'll JSON print it. And look at that. These are the permissions and the paths. Very, very cool. We can actually cron it, use the cron tool that Tom Nom Nom invented. So that's very nifty. It makes me realize that we should remove these from the list entirely. If permissions reaches 0, there's no need to keep them in the vector anymore. So let's see, then we need to iterate with a number. So that we have an index to remove. I can do this. Okay. So, if new permissions, then unveiled paths remove I. Cool. Okay, let's try it with that. See that the /dev goes away from the list. Okay. So Windows Server can now only read and in anything in /res, anything in etc passwd, which is just a file, and this specific file right here. Cool. And of course, this is not perfect, but it does feel like a very cool start. And this, we shouldn't have this. I think this is used to figure out the path of this thing, and it's also used to figure out what name we should show here. We can probably let it look in that file. It's not the end of the world. But I do quite like the idea of having a config server or a settings server or whatever. It's something we've talked about before, and I think it would make sense to do that because I don't like the idea of everyone mucking around with the files, especially if you want to write to some user config file. Having all of that happening in a single place feels nice. And then you can lock everyone out, and then you can be the only one that has access, and so on. Let's tidy these up a little bit, though. Permissions. We could do them as a string instead, for example, just because it would look neat. So, string builder. If unveil path permissions and access read. Or actually, we can just use a simple buffer for this. But no, I like this type of API. I'm just going to use it, whatever. If we shouldn't prematurely optimize here, so let's just append an R, read, write, execute, create or remove. Okay. That looks so nice, dude. I love it. All right. Let's commit some stuff. What are we looking at here? All of the, we'll add process. We can do the proc fs thing by itself. Process h, Syscall h, and let's see, std kernel, add a basic implementation of unveil. This is called is a complement to pledge. We call it sys unveil. Sometimes I like to write sys, like syscalls like that. I guess it's kind of cool. But in this case, I feel like doing it that way. So whatever. Which adds the same sort of access. Incremental access relinquishing same sort of incremental relinquishing of capabilities for file system access. The first, each call to unveil, the first call to unveil will drop the veil, drop a veil on the process, and from now on, only unveiled parts of the file system are visible to it. Each call to unveil adds or updates specifies a path to either a directory or a file, along with permissions for that path. Unless a path has been unveiled, attempts to open a file that has not a path that has not been unveiled will fail with int. If the path has been unveiled, but not with the open without permissions that matching what the process. How do we express this? If the unveiled path lacks sufficient permissions for it will fail with access. The permissions are a combination of read, write, execute of the following. Read. And see, create, remove access. Like our path. The R path promise, like the W path promise, like the, it's not really like any promise, I suppose, like the C path promise. And maybe we should put them like that. Now RWX feels better, more organized. Okay. Finally, then your like pledge subsequent calls to unveil with the same path can only remove permissions, not add them. Once you call unveil opener, it is no longer possible. The unveil is locked, and it's no longer possible to unveil any more paths ever. For the process ever. This is the idea. The idea for this, or this concept comes from OpenBSD, and their implementation does various things differently. I'm sure this is just a first implementation for Serenity OS, and we'll keep improving on it as we go. Oof, long text. Okay, and then we can just add proc fs, add proc hid unveil. This JSON, this file exposes a JSON array of all the unveiled paths in a process. Did that look sane, by the way? Unveil. It's a little bit weird that it's world readable, isn't it? Why is it world readable? Why do we let other people look at our things in proc? I mean, I guess nobody can get in there anyway, so maybe that doesn't matter. Yeah, so you can't even get into these directories unless you are the owner of the process. So because I own Windows Server, I'm running that process, then I can go into 12. And then stuff in here has more lax permissions, but it doesn't actually mean anything. So maybe we don't care about that. What happens if we look at some other process? 17, JP, unveil. Yeah, this shell process has not unveiled anything. That's perfectly logical. We needed to fix the ID program. So then, let's make sure that it works. But so I know that on OpenBSD they actually do this a little bit differently. They have a pledge that you can make that allows you to access these files, but I think I would rather not make pledges that hardcode file system paths. I feel like that's a little bit strange, so it just seems kind of nicer to have to specify them in the program in user space. So now it works. That's very cool. So commit userland ID. This will be our first little tester. Use unveil. Our first user of unveil become and so int comes our first user of unveil, giving himself access to read etc pastdbd and etc. I'm not going to write out this prose for each time I do this, but just wanted to put one of those guys. Cool. Last time that when I committed the pledge changes, I made such a stupid mistake. I like put all the pledge changes in the wrong commit. I didn't realize until I pushed. It's like I had a big commit message about implementing pledge, and then I used pledge in ping, and then I put all the pledge changes in the ping commit, and I don't know, it was just a mess. So I'm just checking now that I didn't actually do the same thing again. This looks better. All right, so then we have Windows Server. Windows Server use unveil. So it's actually kind of interesting how this is going to have to work. So window this Windows server needs access to a few things. As for themes, fonts, cursors, apps, etc. Wallpapers, etc. Temp needs persistent access to a few things and temporary access to something. So, these things are unveiled temporarily and then dropped. Then for setting up sockets. And /dev for opening input devices, input and frame buffer devices. Because once they're open, then you can still like use the devices and you can IO cuddle on them and whatever you want because you have a file descriptor. So unveil is just going to lock you out from opening any other things or like doing any path resolution. Let's see, pass DVD for username. Lookups. And I'm not super sure. I'm not sure about this one. TBH. I'm sure this is actually needed. And home anon window manager. Fix me. This should not be hard. This should not be hard coded here. So this is really cool. This leaves Windows Server running with a very limited view of the file system. How neat is that? I think that's very neat. So yeah, I'm not going to go crazy with putting this in all the different programs right now, but I just wanted to do two, one simple one like ID and then a more complicated one like Windows Server. And this is going to take a lot more work to get right, but at least we can start here because I think the API is sound, and then we can start to apply it in various programs and see what we discover. So yeah, unlike Pledge, I'm not gonna put all of the unveiled paths here because it would be kind of annoying. Although maybe we could show them down here. That would be kind of cool. Frick. Let's do that. So apps, system monitor, process, file descriptor map widget. We'll just copy him. Process unveil paths widget. Okay, let's see how fast we can implement this. Okay, process unveil paths widget. Blah blah blah. And thank you, Past Andreas, for inventing the GJSON array model. This is actually might be pretty easy to do this. So, oh, I haven't used this for quite some time, but let me just change the path here. And then we just have to change, the GJSON array model, I did a bunch of videos on this in the past. So it basically uses a field specification that tells the model what kind of fields are in this JSON, and then how should they be presented in the table view. So we'll have path, center left alignment, and permissions. Oh, this is going to be so straightforward. And left alignment, and then we just plop, and we can call these PID unveil fields. And wouldn't it be super cool if this just super worked right away? Oh, wait, we forgot to instantiate it. I got a little carried away there. Memory process file descriptor map widget here. So we'll just add him next to this guy. So call it unveiled paths. And paths widget process unveiled paths widget. Is that what it was called? Oops. Okay. Look at that. Unveil paths. Oh, wait, it looks so wrong. Wait, what the actual heck? Oh, wait, frick. I totally messed that up. I forgot to give it the right thing. There we go. Wow, that looked really strange when you hooked it up to the wrong widget. So I guess I put the same widget twice into the tab widget. Very, very goofy. All right, come here, you. Unveil paths. Of course, now there's nothing, but if we look at Windows Server, we have to update it. I'm getting too excited, and I'm like trying to get everything to work without having to actually touch anything. So how does this get updated normally? Open files. Oh, we set them here. Call setPID. Unveiled paths widget. SetPID. I think that's how they get updated. Okay. 38th time is the charm. Come on now, system monitor. And there we are. Okay, so now we can see the unveiled paths for this process and the permissions. That's really cool. And of course, if we look at somebody who hasn't unveiled anything, then we see nothing. But here we can see. I like it. All right. Oh, I almost forgot. Paths system monitor process owner paths widget. System monitor. Add an unveil paths. Section to the per process tabs. This shows the data from park PID paths. No, unveil. A nice table view. So many happy smileys today. All right, so I think that this is going to be it for today's video. So if you made it this far, then I thank you for watching. And I hope you saw something interesting here and that you think that this mechanism is cool, because I think it's really cool. And I look forward to using it more, to just restricting more parts of the system so that we can just have a very small attack surface in as many places as possible. Just lock things down. It's such a nice it's a nice way to harden your system, is to just not expose too much of it. Anyways, this was really fun, so I'm really happy with this initial implementation, and we'll keep working on it. And if you are interested in helping out in making this better, or maybe applying the unveil pattern to some programs in Serenity, then feel free to work on that. I think you can do it just the way that you just saw me doing it, that you sort of iterate and try. You unveil some stuff and see what else is needed based on what the debug log tells you is missing. Anyway, yeah, thanks for watching. And of course, I should mention more often that if you're interested in supporting my work, then I am on Patreon and GitHub sponsors, and you can find all of those kind of things in the description below. But that's also fine if you are not interested in that, because it's all good. Anyways, huge thanks to everyone who does support me on those platforms. I really appreciate it. And I'm going to stop talking now, and have a great time, and I will see you next time.